Continuing lesson 1-2 on understanding irrational numbers and I suppose rational numbers as well. If you look at page 16, the do you know how number 4. So they are asking on number 4 whether this number is rational or irrational. If you'll notice, we do have some stuff after the decimal point. So kind of the question is going to be, after the decimal, is it repeating or not? And then if it's not, obviously it is continuing forever. So our main question here is whether this is repeating or not. And so 4, 3, 4, 9, 2, 2, 4. I don't see any pattern there. That's not repeating. It keeps going forever, and so that is going to be irrational. Okay, so it's irrational. For an explanation, you could say the decimal keeps going and doesn't repeat. If we look at number 6, they want us to classify these numbers as rational or irrational. So once again, if the decimals keep going and they don't repeat themselves, it's irrational. Otherwise, it's rational. You can think of rational as a ratio fraction with two integers, or it can be written that way anyway. But basically, irrational decimals keep going and don't repeat is maybe the easiest way to remember it. So one of these, if you look, this middle option here, decimals keep going and that's not repeating itself, so that would be irrational. They didn't give us much room to write all that, did they? Good thing it's on the right side and not the left. So we keep looking here. We've got the decimal just beside that. That's terminating decimal. It ends, so that's rational. We could, if we wanted to, write it as 375 over 1,000. And we could even reduce that if we want. This first option over here, 4.27, the 7 is repeating. Since it's got a repeating part on it, it is rational. Okay? Since it doesn't repeat right after the decimal, we can't use our little trick. We'd have to use the way the book was showing us how to do that. But it is rational. Anytime you have repeating, rational. They both start with R's even. And if we look at the last option here, negative 13 over 1, that would be rational. It is exactly in that form. It's a fraction with two integers. One thing I'll just mention here, they put the negative right next to the fraction bar. I'm going to put it up in the numerator because otherwise, if you're not very careful with that, that negative sign can blur into your fraction bar and you might not see it anymore. You might think it's 13 over 1 instead of negative 13 over 1. And finally, we have the square root of 62. It's pretty close to something. Square root of 64 is 8, because 8 times 8 is 64. But square root of 62, we can't get a whole number times itself to equal 62. So that one is going to be irrational. We're going to look at a couple problems in your workbook. This is actually on workbook page 3. Workbook page 4. Page 3 is the start of the front side of this, and the page 4 is the back side of this worksheet. So workbook page 4, number 9, they're asking which of these numbers are rational. So you can see the options there, and then it's a multiple choice question. So we'll just look through these numbers, say if each one, whether it's rational or not, and then we will come up with our conclusion here. So if we look at our first decimal, 3.222222, ... Okay, that we could write it like this. So that's a repeating decimal. So that one is rational. Repeating is always rational. We could write it as 3 2/9. and then we could change it to an improper fraction if we want. Our second option, we got some kind of a pattern going there. We just keep adding the next number, I guess, sequentially. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. It's a pattern, but it's not repeating, and it keeps going, so that one is irrational. Our last option here, the decimal ends. So if the decimal ends, for sure it's going to be rational. And we could write that as 1 and 589 thousandths, and then we could write it as 1,589 over 1,000 if you wanted, which would be a fraction with two integers. Okay. Again, the idea with rational, it can be written in that format as a fraction with two integers. So anytime if it ends, we can write it as a fraction, and then we could write it as a fraction with two integers if we wanted. So the question, which of these are rational? So we had 1 was rational, Roman numeral 1 and Roman numeral 3. So 1 and 3, which would be choice D. Number 10, they want us to classify these numbers as rational or irrational, similar to what we did in the book a minute ago. So if we look at these, we've got one here that's a big long decimal, keeps going, doesn't repeat itself, so that's going to be irrational. Okay, 3.14159265535, and so on. And that is pi, keeps going, doesn't repeat. If we look right before that, we have 2/3. 2/3 is a fraction with two integers, and so that is rational. Remember, rational, first part of rational is ratio. We can write it as a ratio or fraction with two integers. If we skip over to 15, 15 we could put as 15 over 1, which is rational. We've got also a repeating decimal here, 7.4 repeating. Repeating is rational. We could write that 7.4 repeating. We could put as 7 and 4/9, and then we could change it to an improper fraction if we wanted. Over on the far end, we've got the square root of 3. Square root of 4 would be 2. Square root of 3 is not going to come out evenly, though, so that is irrational. If you type that in your calculator, it's going to fill up your screen, and the calculator is actually rounding that last digit off. We've got another square root on here, square root of 1. So think of a number times itself that equals 1. That would be 1. So square root of 1 equals 1. And we could, if we wanted to, write that as a fraction, 1 over 1. 1 divided by 1 is 1. So square root of 1 would be rational. And finally, 0. 0, you could actually put 0 over any number. 0 divided by any number would be 0, other than we can't do 0 divided by 0. So that would be rational. Okay, so this gives you an idea of how to categorize rational and irrational numbers. Have a good day.